Hello everyone, I'm Dakota Murray, and today I'm standing in for our wonderful team. This project began with a question. What happens when you put a lot of archaeologists, biologists, economists, and physicists into a room together for a month? Well, something like this happens every year at the Santa Fe Institute's Complex Systems Summer School, the premier workshop for students, faculty, and professionals in the field. In this month-long program, diverse participants work with their peers to undertake one or more original research projects. Since these projects are not tied to funding or evaluation expectations, the summer school provides an ideal environment for interdisciplinary collaboration. So, does the program fulfill its goal of encouraging collaboration among varied people on interdisciplinary research? To examine this, we manually extracted data from the publicly available wiki pages used to manage the summer school program between 2005 and 2019, resulting in demographic information for 824 participants, including their gender, country of study, professional position, university prestige, and discipline. We also extracted project details using their final submitted project papers. We find that participants come from a wide variety of disciplines, the most common being life sciences, social and behavioral sciences, physics, computing, engineering, and math. Most participants were current students in academia, and about half were affiliated with organizations in the United States, and men outnumbered women across all years of the summer school. We built collaboration networks for each year of the program, in which nodes represent participants and edges represent collaborations between participants on a group project. Using the network structure in each year, we test the extent to which participants' demographics relate to group formation. We quantify the degree of demographic homophily of the network using an aggregate of participant homophily scores, calculated using the Herfindahl-Hirschman index, which we shorten to HHI. This is compared against a null model that assumes random mixing in group formation. Over 500 simulations, node identities are randomly shuffled and HHI calculated based on each demographic characteristic. For most characteristics, group formation is consistent with random mixing. However, for discipline, we find greater HHI than expected, evidence of homophily in group formation. This suggests that participant discipline is important to group formation. So, let's dig deeper into who works with who. Using the same shuffling procedure, we look at the actual number of collaborative pairs compared to the expected from random mixing. Red means more than expected, and blue means less. The number is the actual number of these pairs across all years of the summer school. We find that disciplinary homophily is driven by only a few fields, particularly in traditionally hard sciences like computing, engineering, physics, and math and statistics. There are also some fields that collaborate more than expected given chance, such as physics with engineering, health with math and statistics, and computing with social sciences. So, once a group is formed, what kind of project do they actually end up working on? Here, we show the relationship between the proportion of participants by discipline against the proportion of project disciplines. Social science projects were especially overrepresented given the number of participants. In contrast, hard science projects were underrepresented, such as those in physics, engineering, and math and statistics. So, what does this all mean? Well, group formation at the summer school is mostly consistent with random mixing, except that participants tend to work with others from their same discipline. Particularly, those in hard sciences tend to work together. However, when it comes to selecting a project topic, groups are quite likely to work on social science projects. So, does the Complex Systems Summer School fulfill its goals? We find that mostly, yes. But discipline still has an impact on collaboration and project choice, something to be aware of both at the summer school and for interdisciplinary collaboration more generally. Thank you so much for listening to our presentation. Feel free to reach out to us on Twitter or by email with any questions or comments. In the meantime, I hope you enjoyed the conference.